Döhler is a multinational corporation specializing in natural ingredients, fruit juices, compounds, flavors, emulsions, basically anything you can add to food or add to drinks to make it taste better. We have quite a number of locations across the globe. Specifically here in South Africa, we focus on blending and secondary transformation. In 2022, we realized we're running out of capacity in our existing production facility. So we had to really plan for the future and really give ourselves the capability to grow not only for the next 3 years, but for the next 10 years. We made the decision to add 10 times the capacity of our existing facility. It wasn't just a gradual growth. We actually had to invest in a new facility. We had to build a new factory, and that created the opportunity to do something greenfields. INTEG is one of the few companies in Cape Town that is gold certified on ignition, and INTEG was able to show a successful project in a similar industry, specifically batch applications, and that really created a bit of ease for us to use INTEG.
INTEG is a specialized system integrator building tailored SCADA PLC and MES solutions for our clients in the water, food and beverage and pharma industry. We pride ourselves on innovative projects, long-term relationships with our customers. Döhler wanted a specific batching system for their new facility. They wanted it to be built on specific standards that they could reuse and that's scalable in a large facility. And they also wanted us to be able to generate reports, batch reports, CIP reports, downtime reports and those type of things.
There are various batching processes within the facility that has to be operated according to ISO 88 standards in order to execute them with excellence. In order to proceed from one station to another, a batch has to be completed. Döhler would have an order, and the order will comprise out of many batches. Each batch leads into the next batch, with the final batch being a transfer into the truck or into a bin. Each individual batch has to be QC released before it can move on to the next process. Each batch will have a purchase order number and will then run till completion. When the next phase of the product has to be produced, a new batch will be created, at which stage the operator can then just execute the batch on that specific piece of equipment. The batches are very important for CIP. Each piece of equipment on the plant has to be CIP'd before a batch can be executed for production. And then it's also extremely important for us to have a good history of our CIP so that there's traceability to see what the CIP parameters were during that specific process. The project also required for us to implement the best and the most modern technologies that's available.
We needed to be able to do fault finding, troubleshooting. We wanted it to be easy for operators, mainly daily operations that had to run very smoothly. We knew we're going to have to work with a lot of vendors, a lot of people with their own technologies, with their own requirements. We wanted something that wasn't specifically connected to a technology, but something that's very open and we can throw almost anything at it and we'll be able to handle it. And Ignition delivered on all of that.
Yeah, INTEG was very happy that Ignition was chosen by the client for this specific project.
Being a greenfields project, the scope had to be explored as the project evolved over time. It is very hard to know how the operators would operate the plant. Therefore, it was important for us to develop features within the Ignition application that made it easy for the operators. Having implemented a SEPAsoft implementation into this project for batch, we needed to find ways to get the operators an interface that is easy for them and is very repeatable for them day-to-day lives.
The HMI design was a very important part of this application. They opted not to have a large control room. They wanted the operators to be at the equipment that they are busy operating. So we've got multiple HMIs all over the plant floor. From there on, we had to determine how would the operators navigate a complex and large facility like this. It's easy to build a lot of P&ID pictures and confuse the operators. So we developed different layers in which we show the plant. In the top layer, it's overview tiles of specific areas with simple routes to show where these equipment are feeding to or feeding from. On these tiles, the operators can see what the capabilities are, what can this piece of equipment do. And then if you drill down into those tiles, you get to more detail, like a P&ID type of view that can show you the pumps and the pipes and the valves and everything. You've got so much equipment on this plant, so we toned down the HMI look so that only when a specific event occurs that needs the attention of the operator, it would pop up and the operator would see that and they can immediately react to that. Only alarms that is on lines that are in process would activate and would pop up on the screen and would alert the operators.
We have mimic screens, we have overview screens, the representative P&ID screens. That allows all the operators to find a model that works for them. And it also adds that level of comfort for them. Some doesn't like all the lines, so they can look at a supervisory or overview screen. It really does make their life easier, and everything is linkable, everything is trackable. If you click on a faceplate on one screen, that same faceplate will open if you clicked on it on another screen. The standardized look and feel across the whole platform, that allows us to take operators from one section and move them to another section, and really just be able to be flexible in our operations as well. And having the system run on HTML means it was really flexible for us to add screens or to move it from one location to another without having to do major installations.
The architecture of this plant in the beginning was a very standard architecture with one gateway, and that changed quickly when we realized the amount of tags that we had required an additional gateway. So we ended up with one master gateway where the perspective module is installed on, and we ended up with a second gateway being a headless gateway for the second part of the facility. The facility comprises of two sections, and each of these sections ended up to be on its own unique gateway. Each gateway communicates to its own central PLC. This project currently has around 1.2 million tags within Ignition, and those are all exposed tags within the UDT structures. Because we needed all of the information for any whatever reason, we kept these tags exposed to the SCADA, and it makes flexibility a lot better.
Because of the size of the plant, it's difficult to know exactly where each valve is or where each instrument is. And if a fault occurs on the HMI, it's easy to see where that is, but to physically find it in the field is difficult. So we ended up developing quite a bit of features. The search function is one of those features that we built. The search function enabled us to take us to that specific item that the operators could then use to find the instrument in the field that's faulty. Another one is copying and pasting of parameters. To physically input each parameter for each valve or each sensor is a tedious process. So the guys developed a function where they could copy and paste these parameters and just make small adjustments to the specific instrument. And similar with a trending tool, opening up a trend tool with a whole list of instrumentation on the left-hand side, and to go in there and to go select certain instruments or values to trend is difficult, especially for people that don't know the plant. So we built the function where they could easily, from a faceplate, add those values onto the trend tool and build the trend tool from the SCADA interface instead of going onto a specific page and try and build it from there. The breadcrumb system is a function that we built for navigation. It's the easy way of taking you exactly to that specific area. It's developed in a logical way, so if you just know the plant and you know where you want to go, the breadcrumb would easily take you there.
We developed a breadcrumb system to display the number of alarms depending on their severity and filtering them down to the specific area or process cell. It aids the operator to identify problem areas within the plant and quickly navigate to those problem areas using the alarming module within Ignition. We were able to integrate this alarming system with the breadcrumb system to allow maintenance to pinpoint to where these problems are up to the control module level. The ID generation system was built to provide a unique code or unique identifier to every single component, whether it's a control module or a phase or equipment module or a unit within the structure of the project. It was easy using Ignition's scripting tools and database integratability.
Because this is a food and beverage facility, data integrity, quality of product and traceability is very important for the client. For that reason, a lot of information is being historized so that if something occurs, we could go back and we could go determine the state of specific valves, of pumps, of instruments to determine where the mistake could have come in. As part of the batching standard that we've developed, we've also implemented a unit state. The unit state determines whether the equipment is dirty or clean or being washed or CIP'd, and that is used to interlock specific systems or specific equipment. It allows the client to easily operate their plant without them having to worry about contamination or having any problems with quality and so on. We've also developed a quality control portion of this system. So once a product has been completed, it goes through a complete quality control procedure where they extract some of the product and it goes to a lab, it gets tested. The SCADA system manages that.
One of the unexpected benefits was actually the ability to handle complex recipes, more complex than we actually imagined. We didn't know we were able to load those recipes in those detail. That really makes our lives a lot easier by telling operators in a step-by-step fashion what to do.
Ignition provided the flexibility, the agility, and the required tools that we needed to bring a project such as this to life with excellence. This was never possible with any other product that we've used in the past. With Ignition, this makes it easy for developers to express themselves more deeply within the SCADA systems.
From the operational side, what impressed me there was the operators picked up on a complex plant very easily. In a short period of time, they were able to operate the plant and get product out the door.
Ignition offers exceptional support, and as well the support that we received from Element 8, the distributor in South Africa, made this possible for us, and they had our back all the way.
We are in different time zones, but both the Inductive Automation and Sepasoft teams were there to support to get this project where it is today.
No one ever said it was too difficult, or this is getting frustrating, or this is really not going to be a success. The team took it on. They were really happy to be part of it.
There's almost no limit to what Ignition can offer a client. The limit would just be the engineering capability of the engineer behind the designer.